The Big Bang Theory is one of the most important scientific concepts in cosmology, providing a framework for understanding the origin and evolution of the universe. At its core, the theory proposes that the universe had a singular beginning approximately 13.8 billion years ago, expanding from an incredibly hot, dense state into the vast cosmos we observe today. This narrative is supported by a wide array of empirical evidence and theoretical underpinnings that make it the leading explanation for the universe's origin. The Big Bang Theory posits that the universe began as a singularity, a point of infinite density and temperature. This initial state underwent a rapid expansion, often referred to as inflation, which set the stage for the creation of all matter, energy, and even space-time itself. The term Big Bang was first coined by British astronomer Fred Hoyle during a 1949 BBC radio broadcast, though he intended it as a dismissive critique of the idea. Despite its somewhat misleading name, the theory does not describe an explosion in space, but rather an expansion of space itself. The development of the universe from the Big Bang can be broken into several key stages. The Planck epoch marks the earliest known period of the universe, during which all fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were unified. The conditions during this time are not well understood due to the lack of a quantum theory of gravity. During the Grand Unification epoch, gravity separated from the other forces. The strong nuclear force became distinct, leaving electromagnetism and the weak nuclear force unified. The universe underwent an exponential expansion known as cosmic inflation during the inflationary epoch. This rapid growth smoothed out irregularities and set the stage for the large-scale structure of the universe. As the universe cooled during the quark epoch, quarks, the building blocks of protons and neutrons, began to form. At this stage, the universe was a hot, dense plasma of elementary particles. Quarks combined to form hadrons, such as protons and neutrons, during the hadron epoch. Antimatter also existed in this period, annihilating with matter and producing photons. Protons and neutrons fused to form the nuclei of light elements such as hydrogen, helium, and trace amounts of lithium during nucleosynthesis. This process is known as Big Bang nucleosynthesis and determined the primordial chemical composition of the universe. Electrons combined with nuclei to form neutral atoms during recombination, allowing photons to travel freely through space. This event is what we observe today as the cosmic microwave background radiation. Over time, matter began to coalesce under the influence of gravity, forming stars, galaxies, and larger cosmic structures during structure formation. These developments continue to shape the universe. Numerous lines of evidence lend support to the Big Bang Theory, making it the most widely accepted cosmological model. Key observations include the cosmic microwave background radiation, discovered in 1965 by Arno Penzias and Robert Wilson, is faint radiation that fills the universe, serving as a remnant of the time when the universe became transparent. Its uniformity and slight fluctuations provide a snapshot of the early universe. Redshift and the expanding universe, as observed by Edwin Hubble in the 1920s, revealed that galaxies are moving away from each other, evidenced by the redshift of their light. This observation supports the idea of an expanding universe, as predicted by the Big Bang Theory. The abundance of light elements, such as hydrogen, helium, and lithium, observed in the universe aligns precisely with the predictions of Big Bang nucleosynthesis. The large-scale structure of the universe shows that the distribution of galaxies, clusters, and voids across vast cosmic scales is consistent with the initial density fluctuations amplified during the inflationary period. Galactic evolution and star formation allow observations of distant galaxies to provide insights into the universe's history and validate theoretical models of cosmic evolution. Despite its overwhelming success, the Big Bang Theory does not answer all questions about the universe. Some of the most significant challenges include the singularity problem, where the theory begins with a singularity where the laws of physics break down. A unified theory of quantum gravity, combining general relativity and quantum mechanics, is needed to fully understand this initial state. Dark matter and dark energy observations indicate that ordinary matter makes up only about 5% of the universe, while the rest consists of dark matter and dark energy, whose nature remains mysterious. The horizon problem presents a challenge, as the uniformity of the CMB across vast distances is difficult to explain without invoking inflation, but the exact mechanism of inflation is not yet fully understood. Baryon asymmetry highlights that the universe contains significantly more matter than antimatter, a discrepancy that is not entirely explained by current theories. The Big Bang theory has profound implications for our understanding of the universe and our place within it. It demonstrates that the universe is dynamic and constantly evolving, challenging earlier notions of a static cosmos. Additionally, it highlights the interconnectedness of all matter, tracing everything back to a common origin. The theory also provides a framework for exploring fundamental questions about time, space, and the nature of reality. By studying the universe's beginnings, scientists gain insights into the fundamental forces and particles that govern existence. The Big Bang theory is a cornerstone of modern cosmology, offering a comprehensive explanation for the origin and evolution of the universe. Supported by extensive observational evidence, it provides a robust framework for understanding the cosmos. While many questions remain unanswered, ongoing research and technological advancements continue to refine our knowledge, bringing us closer to unraveling the mysteries of the universe.